So in this video of chapter 8 quadrilaterals, we are going to see an important property that every triangle has, and this property is called as midpoint theorem. Okay, so it's related to the triangle geometrical figure, not quadrilateral. So let us see what is midpoint theorem. Okay, so what is midpoint theorem in a triangle? So let us first draw a triangle for the sake of our understanding. So this is a random triangle. Okay, let's name it. So A, B, C. These are the three sides of a triangle. Now, what does the midpoint theorem say? As you can guess from the title that we need to find midpoints of two sides and then the theorem is involved. Okay, so let's take midpoint of the side AB. Let's say, okay, I'll use a different color. Let's say this is the midpoint of side AB and this is the midpoint of side AC. I'm going to name them P and Q. Now let us join a line from P to Q. Let us construct a line from P to Q. So this is a line from P to Q. Now first thing you should do is, if you measure this length of line PQ and if you measure the length of line BC, you will observe that the first observation. Okay, I will write here observation. Okay, the first observation is that PQ, the length of PQ is equal to half the length of BC. Okay, so the length of this side PQ will be half of the third side BC. Okay, that's the first observation. And the second observation is with respect to angles. So if you measure the length of this angle, sorry, if you measure the value of this angle and if you measure the value of this angle, which is our angle B, this and this, you will find they are same. Measure of length APQ is equal to measure of length ABC. So I'm going to write that down. That is the second observation, that angle APQ is equal to angle ABC. And what does this mean? So if you observe, these are two corresponding angles, okay, for the two lines PQ and BC. Okay, considering AB as a transversal and PQ and BC as two lines, these two angles are the corresponding angles. And we have seen this in the previous chapter of lines and angles, that if the corresponding angles are equal, then the lines are parallel to each other. So since this is observed that APQ is equal to ABC, that means that is PQ, the line drawn, is parallel to the line BC. Okay, this line PQ is parallel to the line BC. So let us summarize what is the midpoint theorem in a triangle. So the midpoint theorem says that if you connect, okay, before that let's get rid of this highlighted things. Okay. Okay, so now the midpoint theorem says if you draw a line connecting the midpoints of any two sides of a triangle. Okay, here we took AB and AC. You can take AB and BC, or you can take BC and AC. Any two random sides of a triangle, you find their midpoints and you connect the line. Then these two things hold true. First of all, the length of the line will be half the third side. Okay, the length of this line will be half of the third side. And secondly, we will say that this line is parallel to the third side. That is nothing but a midpoint theorem, a very interesting theorem found in triangles. So just to generalize it, I'm also going to yes, so let's draw a line here. So let's draw different midpoints in a given triangle. So first of all, let's draw a triangle here. So here I'm going to draw a triangle. Okay, not a great triangle. Yes, and let's name this triangle as PQR. Okay, so let's take this as a midpoint and this as a midpoint, and once again draw a line. So I'm going to draw this line here. Okay, let's name it, let's call it X, okay, and Y. Okay, so according to the midpoint theorem, we can say two things. First of all, length of xy will be half the third side. Okay, what is the third side? The third side is PR. So length of xy is half of PR. And secondly, we will say xy will be parallel to PR. Okay, thus the midpoint theorem in a triangle establishes two important relationship between the line, okay, the line joining the midpoints and the third side. This is one relationship in terms of their length, and this is one relationship in terms of the parallel characteristics. So this is what is a midpoint theorem in a triangle. Now we have to prove this midpoint theorem, and the proof of this midpoint theorem is a little bit tricky. Okay, it's a little bit lengthy, not really complicated, but lengthy. So let's see how we can prove the midpoint theorem. Now once again, let us first draw the triangle. So this is our triangle in picture. Okay, let us take the two midpoints of the triangle. So let this be the midpoint and this be the midpoint. I'm going to draw a line connecting these 2 points. So like this. Okay, let's name all these values. So these points will be A, B, C, and this line is P and Q. I think so. This should be like this. So this is P and this is Q. Okay. Now, so this is our given triangle ABC, and we have connected the two midpoints of the two sides AB and AC, and we have to prove these two things. Okay, we have to prove these two things, 1 and 2. So let's see how the proof proceeds. So first of all, so our step 1 is going to be a construction. So I'm just going to note it down here. Step 1 is construction, and what is that construction? Okay, so now focus on this point C. From this point C, we are going to draw a line, okay, which will be parallel to AB. Okay, draw a line which is parallel to AB. So construction from vertex C, draw a line parallel, okay, parallel to the side AB, parallel to side AB. So our line will look something like this. Let me try to draw a line parallel to this. So okay, so this line is parallel to the side AB, and now this line PQ we will extend till it connects this point, connect this line. So okay, so I will just extend this line, okay, and it intersects the line at this point. Let's call it, okay, let's call it R. Let's call this point as R. Okay, so fine. So this is a construction from vertex C. Draw a line parallel to side AB. So we did that, and the second thing is extend. Oh, sorry. Yes. So extend PQ, extend line PQ till it meets, okay, the parallel line, at point R. So I'm going to write it at point R. Okay. So this is the construction that we have done. Now our focus is going to be on these two triangles. Okay, I'm going to use a highlighter. So this triangle APQ, okay, and this triangle CRQ. These are the two triangles that we are going to focus on. So now let's come here. Okay. So I'm going to do one thing. I'm going to just copy this whole thing so that, okay, copy and just come down. Yes, and let's paste it here. Paste. Yes. So now this is, so construction step number 1. Now step number 2. In triangle APQ and triangle CRQ. Now we are going to try to prove that these two triangles are congruent to each other. Okay, triangle APQ is congruent to triangle CRQ. How is that possible? Let's see. Step number 1. So we know that angle AQP, okay, so this angle AQP is equal to angle CQR, okay, because they are vertically opposite angles. Quite. So AQP is equal to angle CQR. Okay, why so? Because they are vertically opposite angle. That is the first thing. Now second thing is, now focus on this. I'm going to in fact draw a separate line, separate diagram. So this is our line AB. Let me use the straight lines thing. Okay, so this is a line AB, and this is the CR which is parallel to AB, and AC is the transversal between these two parallel lines. Okay, I'm going to name it. So this is our line, this is our vertex A, this is B, okay, this is C, let's say this is R, okay. So AC is a transversal for two parallel lines AB and CR, okay. This is our AB and this is CR, and AC is the transversal. So this BAC is equal to ACR. Why? Because they are alternate interior angles. We know that if we draw a parallel line and if this is a transversal, then the alternate interior angles, let me use a highlighter, these alternate interior angles are equal to each other. So similarly, here this angle, again this angle is going to be equal to this angle, which is, so I'm just going to write here angle, okay, angle PAQ is going to be equal to angle RCQ. Okay, why? Because there are alternate interior angles for them, for this line and this line parallel and this as a transversal. So that's the second point. And the third point is side. Now side AQ is equal to side CQ. Okay, why so? Very obvious, because Q is the midpoint of the segment AC. So AQ, okay, let's try to erase this so that the confusion is reduced. Okay, so now, yeah, so AQ, this AQ will be equal to CQ, because Q is the midpoint of the side AC. So side AQ is equal to side CQ. Okay, so now, so in triangle APQ and CRQ, we have two angles equal to each other and one side equal to each other. So by ASA test, okay, angle side. So just let's make a quickly note of that. Therefore, by angle side test of congruency, we can say that triangle APQ is congruent to triangle CRQ. Now this is an important conclusion. Triangle APQ is congruent to triangle CRQ. So okay, so in fact I'm going to again copy this, because this is an important thing that I'm going to need. All right, okay. Oh my, why is it not getting copied? Okay, copy. So let's come here for more understanding. Yes, paste. Yes. So by AA test of congruency, APQ is congruent to, okay, again let's get rid of this highlighted thing. Yeah. So this triangle APQ is congruent to triangle CRQ. Now, once we prove two triangles are congruent, all the three sides and all the three angles are also congruent to each other. So we get CR is equal to AP. Okay, again let me use a highlighter. So this side CR will be equal to side AP, 1-to-1 correspondings. Okay, so I'll say therefore side CR is equal to side AP. But what is side AP equal to? Now once again, P is the midpoint. Okay, P is the midpoint of this side AB. So AP is also equal to BP, because they are, okay, because P is the midpoint of side AB. But side AP is also equal to side PB. Okay, so now look at this. CR is equal to AP and AP is equal to BP, which means side CR is equal to side BP. Okay, thus side CR is equal to side BP. Okay, so now this is again a very important, I'm going to box it, this is again a very important conclusion that we have come to. Okay, so let us revise what we have done so far. So I'm going to should I erase this? Okay, let me be there. Okay, now focus on this quadrilateral. So I'm going to use a highlighter once again. So B C, R and P. So B, C, R, P. Focus on this quadrilateral. In this quadrilateral, we have CR as parallel to BP by construction, and CR is equal to BP. That is what we proved just now. Okay, CR is equal to BP. So opposite sides of a quadrilateral are parallel and equal to each other, which means that BCRP is a parallelogram. Very important. Okay, so I'm just going to make a note of this point. Okay, so CR is equal to CP and CR is parallel to BP. Okay, why? By construction. That's how we constructed the line CR, by construction. And thus, okay, thus BCRP is a parallelogram. Okay, that's an important conclusion that we have come to, that BCRP is our parallelogram. Now, once again, let's create a copy of this so that I get a space. Oh, copy. So let's come to a new page. Paste. Okay. So we have concluded that so we have concluded that BCRP is a parallelogram. So now again, if BCRP is a parallelogram, then first thing, then PR is parallel to BC. Okay, why? Because opposite sides of parallelogram are parallel to each other. So very clearly, this PR will be parallel to BC, which means PQ is also parallel to BC. Okay, because PQ is part of PR. That is, PQ is parallel to BC, and this is the one of the points of midpoint theorem, that this segment PQ is parallel to BC. Okay, and the second thing we have to prove is PQ is half of BC. Again, that's a very simple thing to prove. Let's come here. Once we have proved that this quadrilateral is a parallelogram, the other things are quite easy to prove. Now, how do we prove that? So, BC, okay, is equal to PR because they are opposite sides of parallelogram. Now, we have also proved that this triangle is congruent to this triangle. I'm going to note it down. We have proved, what did we prove? The triangle APQ is congruent to triangle CRQ. Okay, therefore we can say, what can we say? Now once again I'm going to erase this highlighted thing. Yes, oh sorry, so we have proved that these two triangles are congruent to each other. So we can say that PQ is equal to RQ, okay, because this PQ is equal to RQ. So we can say side PQ is equal to side RQ. Okay, that is, what does this mean? Q is midpoint. That means Q is a midpoint of PR. Okay, very important. Since this PQ is equal to QR, so I can give this markings. In fact, we can say that PQ is equal to QR. That means that this Q is midpoint of PR. Okay, what does that mean? If Q is a midpoint of PR, that is PQ, the length of PQ is equal to half of PR. Okay, PQ is half of PR, but PR is equal to BC. Why is PR equal to BC? Because it's a parallelogram. This whole thing is a parallelogram, and opposite sides of parallelogram are equal to each other. This is an important property of parallelogram. So PR is equal to BC. So I can substitute instead of PR this value BC, and therefore I'm just going to say here, okay, therefore PQ, okay, is going to be equal to half of BC. and I'm going to box this because this is the second and the second point in the midpoint theorem, that this segment PQ is half of the third side BC. We have proven this, and we have also proven that PQ, yes, PQ is parallel to BC, and thus this completes the proof of midpoint theorem. It's a bit lengthy proof and a bit complicated, but we have proven it. Let's quickly revise how the proof proceeded. Okay, here. So first of all, let's zoom in here. Okay, we did an important point. First step was, this was first step. We did a construction. We constructed from this vertex C a line which is parallel to AB, and then we just extended PQ so that it meets at R. Then we proved that these two triangles are congruent to each other. Once we prove these two triangles are congruent to each other, we get this side CR as equal to AP. Okay, if CR is equal to AP, but AP is equal to BP, which means CR is equal to BP. So once we prove CR is equal to BP, then these two sides are parallel and equal to each other. That means this whole quadrilateral is a parallelogram. Once we prove this quadrilateral is a parallelogram, obviously opposite sides are parallel to each other. So PQ, or rather PR, is parallel to BC. So PQ is also parallel to BC. So that's the first thing that we prove, that PQ is parallel to BC. And secondly, since these two triangles are again congruent to each other, so PQ is equal to QR. So PQ will be half of PR, okay, because Q becomes the midpoint. But PR is equal to BC, so PQ will be half of BC. So thus we very confidently prove this midpoint theorem, which had these two important observations.